Hello everyone, so welcome to our second day of solving systems by graphing. So these two problems are stereotypical problems that I want you guys to be able to do. The first thing I suggest is to try these on your own. Press pause on this video, attempt them to see that when I go over them, if you're going down the right path. Now, just for video's time's sake, I'm just going to go ahead and do these problems. So notice I have not gave you a problem like number one, but you do have the knowledge in order to solve it. So let's read the directions and kind of work through it. Given the following equations and their graphs, write the solution as an ordered pair x, y, and check their solution. So I can notice here that I'm given two equations with exact same variables. Remember that whenever you have two equations with exact same variables, that is considered a system of linear equation. So I have a system. In order to solve it, I need to come up with an x and a y, an ordered pair that make both of these equations true. Now, it looks like they did the majority of the work for us. They graphed both these equations on this graph, and now it's my job to analyze the graphs to figure out a solution. Now remember that whenever you have a graph, it represents every x and y combination of that equation. So what they did there is graph one line. They gave me every x and y, a visual of them, and they also graphed another one, the second one. So how do I know where my answer's at? Well, it's wherever both of those equations cross. Now where they cross is right over here. Now, that coordinate point has an x and a y. This is the x-axis, so I'm going to go up to my x-axis and see what x value is associated with that coordinate point, which in this situation is a 1. And then I'm going to go ahead and look for my y, which is a -2. So notice here that that x value of 1 and that y of -2 are the solutions to my system. That means if I were to plug in a 1 into both of these equations, I would get a -2 out for my y. Now, whenever they tell you to check your solution, that is what they're asking you to do. So let me go ahead and do that. I'm going to change colors so that way you are aware of which equation I'm referring to. So I'm going to start with this first one. I'm going to take y is equal to -5 times whatever x is plus 3. I'm going to plug a 1 out to see if I get a -2 out. So y is going to be equal to a -5 times wherever my x is, which is a 1, plus 3. Now remember your rules of PEMDAS, or what you have to do first in terms of all this math. Remember that you want to do multiplication first, so -5 times 1 is a -5. Now that's a plus 3. -5 plus 3 is a -2. So you can see here that when I plugged in a 1, I did get a -2 out for my y. So that is how you check your solution for one equation. In order to check your solution for the system, you have to plug it into both. So that's what I'm going to do there. I'm going to do it up here just for space here. So notice that y is equal to x minus 3. So that means that y is going to be equal to whatever my x value. Remember that we found it to be 1, minus, then we're going to minus 3, and 1 minus 3 is a -2. So again, we plugged in a 1, got a -2 out. This is a solution to the system because, again, we found an x and y that make both these equations true. So whenever I tell you, hey, check the solution, this is how I want you to check the solution. Actually plugging them in and making sure that when you plug in that x, you get that y out. All right, so notice that number 2 is telling me just to solve the system. It's not telling me to check the solution. So a little bit less work. But let's remind ourselves on how we go by doing this. So just like before, they did the graphs for us. Now it is your job to actually graph them. Now, if I look at this equation here, y is equal to 2/3 x minus 2, I can see that my y is by itself. When my y is by itself, I can identify the slope and the y-intercept on the other side. This format is called slope-intercept form. Your slope, which is identified with your m, is 2/3. Your y-intercept is a -2. It's whatever you're adding and subtracting. Now you have to put that information together in order to form a graph. Remember, you always want to start with your y-intercept. Your y-intercept in this situation is a -2. Your slope is 2/3, so you're going to go up 2, 1, 2, and over 3, 1, 2, 3. So those are your two coordinate points. Make sure you try to draw the most accurate line because, again, we're looking for where they cross, so we have to be as accurate as possible. Now let's go ahead and solve or graph our second line. Now notice here that this is, again, in slope-intercept form, so all these problems have been kind of fairly easy because there's not much I have to do to the equation. I just have to identify my slope, which is what multiplies the x, and my y-intercept, which is whatever I add and subtract. And then now I can go ahead and put this in the graph. So the first thing that I notice here is that my y-intercept is 2. So here's my 2. I see that my slope is 2 as well, but I'm going to put it over 1 so that way I can see the change in y over the change of x. So notice here that I'm going to go up 2 over 1. Now I can see that these are going to graph, so I'm just going to follow the pattern backwards. So I'm going to go down 2 in this direction 1, down 2 over 1, down 2 over 1, down 2 over 1. That's why it's helpful to draw your graphs from one end to the other end because you can see where they intersect a lot more clear. Or just use a ruler too. All right, so that's good and all, but remember why we graph these. We graph these to figure out a solution to this system. How do I do that? Well, the only way you've known so far is to graph. You graph both equations. Wherever they intersect is your x and y that makes both these equations true. So what is this x value? It is a -3. What is the y value? Well, the y value is a -4. So if you were to plug in -3 into both those equations would give you a -4 out. So again, that is what you're expected to know from the first lesson. If you don't, well, you're going to get some extra practice. So what we're going to cover today is that we're going to up the difficulty here in terms of graphing. They're not going to be as easy as they were in the past. Now, I have two equations here. I notice that only one of them is in y equals mx plus b. Let me make sure to erase that so I can see it is a 7, which it is. Now, again, why do I care if it's in y equals? Because that means it's in slope-intercept form. That means I can find the slope and the y-intercept by just looking at it. My slope in this situation would be -7. My y-intercept would be 3. So I could use those two pieces of information in order to make my graph. So here is a +3. Notice that my slope here is a -7 over 1, so that means I'm going to go down 7. 1, 2, 3, 4, 5, 6, 7, and over 1. So there is my graph, as crooked as possible, but again, you'll see in a second that hopefully they intersect. All right, so let's look at our second one. Notice that our second equation there is 2x plus 6 is equal to -2y. Now, notice that your y is not by itself, so before you graph it, you have to get it by itself first. That's -2 times y, so the opposite is to divide by -2 on every side and every term. -2 divided by -2 is just a -1. Don't forget your x. 6 divided by -2 is a -3, and that's going to be equal to a y. So notice that now you are able to find your slope and your y-intercept. Your slope is -1, your y-intercept is a -3. Now putting that together, -3 is right over here. I'm going to go down 1 over 1 because that's what my slope tells me to do, so it would be right over there. So luckily for us, it was quite easy to see the intersection point, which in this situation would be the ordered pair x, which is 1, and y, which is a -4. So you'll notice here that these problems are not that much harder. It's just bringing a past skill and doing it now. We're pretty much graphing lines that are not as easy. They're not look and see. You have to provide some work. So let's go ahead and practice this with one more example. This first equation is -2 is equal to 5x plus y. If I look at this equation, my y is not by itself. I have to get rid of everything else around it, more specifically that 5x. So let's minus 5x on both sides. These cancel out. Notice you're left with y by itself, and we have 2 minus 5x. Now we cannot combine that 2 and 5x because they're not line terms, so that means we're just going to rewrite it exactly the way it reads. Now my slope in this situation would be a -5, my y-intercept would be a -2. Let's put this information together to form a graph. Well, here's -2. It goes down 5 over 1 in order for my slope, so I'm going to go down 5, 1, 2, 3, 4, 5, and over 1. You can see that I clearly went off the graph, so make sure you follow the pattern backwards. To go in this direction, I'm going to go over 1, and then go up 5. So I'm going to go over 1 again, and up 5. 1, 2, 3, 4, 5. So that is my graph. I'm trying my best to draw as straight and line as possible. So yeah, that's that line there. Let's go ahead and do the next one. So that is a -4 is equal to a -y plus x. Again, you're solving for y. What do I get rid of first, the negative or the plus x? Always get rid of what you're adding and subtracting. We're adding an x, so I'm going to go ahead and subtract an x. I can't combine those, so I'm just going to rewrite them over. And now it's time to get rid of that negative. Now remember, that's a -1, so what I'm going to do is just divide everything by -1. You end up with a +4. Positive x is equal to a positive y. So what is your slope? Your slope is going to be that +1 that's hidden there technically, and your slope is going to be 4. So here is my y-intercept of 4. I notice I'm going up 1 over 1 because my slope again is 1. So over 1. If I work backwards, I can go down over 1. I can see exactly where they intersect. That ordered pair would be an x value of -1 and a y value of 3. Okay. So that is a large part of what we're covering today, at least the difficulty, is getting the equations ready in order to be graphed. So doing this work is going to be the value today, understanding that you have to change it to y equals mx plus b before you start graphing the straight lines. Now there is a little other piece that I want to add to this. Now notice that when you're solving systems, what you're doing is you're graphing them and you're seeing where they intersect. So usually you have what is called one solution, because let's say I have an equation and I graph a random line like this. And then I graph my other line and they intersect in one place and one place only. Well, where they intersect, I'm going to have one solution. Now, what are other things that could happen? I want you to kind of think about it for a second. Another thing that could happen, you can see where this is leading to, is that if you graph one line and then you graph another line and there is no intersection. If there's no intersection, that means that there is a no solution. Now, you can either tell me no solution whenever this happens, or you can tell me that they are parallel. Parallel just means that they do not intersect. They're going in the same direction each time. Now, sometimes, and you'll notice what I mean in a second, you graph a line, and then you graph the second line, and they're actually the exact same line. They just didn't originally look like that. Now, if they're the exact same line, that means you're going to have infinite solutions, because they are really just the exact same lines, except it's your job to figure out when they are and when they're not. Okay, so again, if they intersect at one spot, one solution. If they don't, that means that it's no solution, if they're parallel, and then if they're infinite solutions, it's if you graph the same line. So what I did here is provide 3 examples of each. You'll notice that they line up right on top of each other, so that way you can see them. So let's start with graphing the first one. Now, luckily for us, this first one here is already in y equals mx plus b, so that means that I know my slope is going to be 2. My y-intercept is also going to be 2. So here is my y-intercept of 2. I'm going to use my slope, which is 2 over 1, up 2 over 1, which is there. Now, just to make sure that I try to draw it as accurate as possible, I'm going to follow the same pattern going down. Well, that's my first equation. Let's go ahead and do the other one. I can see here that my slope is going to be 1/3, and my y-intercept is going to be -3. So where is my y-intercept of -3 is down here. I notice I'm going up 1 over 3, so up 1 over 3. Working backwards, I see that it crosses right there at that point. This point here, if I were to write it, it would be -3 and -4. So how many solutions do we have? We have one solution, because again, there's only one intersection point. So this is a very stereotypical problem of what we've done. Let's see what happens when we do 6 and 7. So let's graph this first one. This first one, again, it's in slope-intercept form. So that means my slope is going to be 3/4. My y-intercept is going to be a -4. -4 is down here. I notice that I'm going up 3 over 4, so I'm going to go up 3. 1, 2, 3 over 4. 1, 2, 3, 4. There is the graph of my line. Let me change colors so that way you know I'm graphing the second one. Notice that your slope is going to be 3/4, and your y-intercept is going to be a 1. So whenever your y-intercept is 1, it's going to intersect the y-intercept there, and I'm going to go up 3. 1, 2, 3, and over 4. 1, 2, 3, 4. So what do you guys notice between these two graphs? That they're never going to intersect. There's no intersection point. So you either have to tell me, hey, these lines are parallel, or you have to tell me no solution. If you leave it blank, I can't really know if you understand the problem or not. So make sure that whenever you draw 2 lines that don't intersect, you let me know what that means. All right, so let's see one more example. So we'll see here that we have y is equal to -2x plus 1. Again, y is by itself. That is really nice because there's no prior work. You just got to be able to recognize your slope and your y-intercept. Y-intercept is going to be 1. Your slope is -2 over 1, so that means you're going to go down 2 over 1, down 2 over 1. So that is what your graph is going to look like for that orange. Let's go ahead and do this blue that looks weird. So let's go ahead and graph this one. Now notice that I have 2y plus 4x equal to 2. Now, what do I have to do? I have to get y by itself, because again, you have to be able to solve for y in order to graph these. So what do I get rid of first? So what I'm multiplying or adding and subtracting. Always get rid of what you're adding and subtracting, which is in this situation 4x. That is y, I minus 4x on both sides. I can't combine these, so I'm just going to rewrite them exactly the way they are. 2 minus 4x. And now getting rid of that 2, I'm going to divide everything by 2. I'm going to end up with y is equal to 1 minus 2x. I can see here now that I have this in slope-intercept form because my y is by itself. I can identify my slope and my y-intercept. My slope in the situation is a -2 because it's multiplying x. My y-intercept is a +1. So if I were to graph this, notice I would end up with a +1, which is there. I'd go down to 1, 2 over 1, down 2 over 1. Notice that my graphs are exactly the same. So what does this mean? That it is infinite solutions. And that says solutions, by the way. So again, if you ever were to graph these lines, notice that it's really hard to tell from the equations at the beginning. It really is until the very end, until you end up with the same equation that you know you have infinite solutions. But that's pretty much it. Yeah.